All right, so I think we've got enough persons to get started. So again, good evening. Again, to those who I already said good evening to, and to those who's joining in. Welcome to DS404, a series of sessions based on data structures and further important concepts that are needed for coding. This is a set of sessions which are conducted by TLE MEC, from which our upcoming chairperson of TLE MEC is going to speak about, and the training cell from where I am from. So welcome to DS404. I would like to remind that this session does have certificates. So if you have joined this link without registering, please do register officially in the form to avail the certificates. Welcome to the session. We'll get started right about now. And stay tuned because our future further sessions are coming of DS404 and you do not want to miss them. And with that, I think Vishruth will get started, right?
Yeah. Am I audible?
Yes, you're audible. That's great. Okay.
Thank you, Sharath. Okay, so welcome all of you to this session. I'm Vishruth from third year computer science, and today I'm going to talk about algorithms and time complexity. So this is the first session in a series of sessions about data structures. So let's get started. Okay, what this session contains. First of all, it contains a lot of unrelatable memes, and then all those other stuff, you can just read through them. And before I start, I want to say something. So if you look at these topics, you'll notice that most of them is purely theoretical. As in this session won't be much, there won't be much of any live coding or anything. And you don't need to know any programming language or anything for this particular session. But since it's mostly theoretical, I would like to have all of you be active, like in the chat. I'll make it interactive. So I want all of you to respond in the chat. Now, don't worry, I'm not going to ask any of you to unmute and speak because I know this is an online session, so none of your mics are working. So can all of you just be active in the chat? So just type something random or just type okay if it's fine with you. And if we can go ahead, anything you can type. All right. And as for this cool swags, so I'll ask some interesting questions in between, and if you answer it correctly, you can win some stickers from, yeah, I'll show that. Anyway, so I think we can get started. Okay. Okay, great. Okay. So first up, why are you even here? Okay. At the end of the session, I promise you, you will be able to understand memes like this. Okay. That's one of the reasons why you're here. Okay. So, okay, seriously, why are you here? So the first thing is to understand efficiency of programs. So as in like when you write programs or, you code, so far, some of you here may have already done programming. Some of you are totally new to programming. But in all these, whatever experience that you have, you may not have thought about efficiency. You would have only thought about getting the output, and that's all. But from now on, you should learn to optimize your programs and to be able to write efficient code, and then avoid getting a TLE. So TLE stands for time limit exceeded. It's an error. It basically says your code is so slow. So you don't want that. You don't want your code to be slow, which is why for that you need to understand how to make it faster. And for that, you need to understand about complexity. Okay, so don't be intimidated by this code. I'm not, you don't have to understand what this is. It's just for an example. So below I have, here I have two codes. It's not exactly code, it's algorithm sort of thing. So some of you here may recognize this. It's called Fibonacci. Have any of you here heard of Fibonacci series? Anybody? Those who know programming, they would have heard of it. Okay, cool. So some of you know what Fibonacci series is. For those of you who don't know, don't worry. It's just like, you have the sequence of numbers where the the next number is generated by adding the previous two numbers. Okay, anyway, I'm not going much deep into that. Don't worry about any of this code. So I just want to tell why this whole thing is important and why we are learning it. So I have two programs here, and the code on the right, on average, for generating the nth Fibonacci number for an input size of 60, it takes 60 nanoseconds. And can you all guess how much time the code on the left would take? I want just random guess. I'm not asking you to calculate or anything because you don't need to know what the code does. Just random guess. Okay, 1 minute. Let's see. The person who gets the closest answer will get a sticker. Okay, I have these stickers from GitHub. I'll give them to you. Okay, 60 what? Apples, pineapples. Give me a unit. Okay, infinity. Okay. 2000 years. So many different answers. 60 coconuts. Okay. I got TLE. 25 seconds. 19. Okay, when you type 19 million seconds and all, keep it to the closest possible unit we have. As in hours, minutes, or something. 2 raised to 60. You guys typing without units. What am I going to make out of it? I want the answer in units of time. Any unit of time. 2 years, 1 second, 60 nanosecond. Come on, just guess random. Okay, wait. There are like, okay, 238 people here. Okay. So all of you can type an answer. A lot of decades. No, that's not acceptable. I need answers to be specific. 3 years. 10 seconds. 50. 2 minutes. 20,000 years. Okay. I'll just wait for 1 more minute. No answer. In 5 minutes. 1 minute. 30 seconds. One hour. TLE. Yeah, you do get a TLE if you run this. That's a hint for you. If you run this in a computer, you will probably get a TLE. A light year. A light year is a unit of distance, right? If I'm not mistaken, if I still remember physics correctly. Anyway, 420 years. Okay. Okay, I think okay, stop. I think that's enough. The answer, you guys gave a lot of answers that are very different, as in some people gave in nanoseconds, others gave in billions of years. Depends on n. Okay, I want the answer for n is 60. I know this depends on n. For n equal to 60 on an average computer, that's what I'm asking. Of course, it depends on the machine and all. We'll see that, but for on average, just to make a point, I'm just doing this. 70 seconds. Okay, I think it's enough. I will find out who is the closest answer, but the answer in this case is, here's the answer. Oh God. Did I not add the slide? Okay, anyway, I think the answer is it's 31 years. Okay, this code takes 31 years to execute for n equal to 60. The exact answer is it's close to 31 years. So I will just go through this chat and I'll get back to you, whoever is the closest, because there's so many answers here. The actual answer is 31 years, and we will see why it's 31 years towards the end of the session. So if you want to know why it is 31 years, if you want the math and all behind it, wait till the end of the session. So yeah, 31 years is a bit too much time to wait for an output, right? I believe it's a bit too much time. So you don't want to write code where you get the output in 31 years. So that's why you're here. You want to write code that's fast, right? No one wants to write code where you wait for 31 years. Okay. Cool, everybody? No response. Just type anything and we'll move on. Anyway, okay. So that brings us to the first topic about algorithms. Okay, engineering is basically about problem solving. Okay, we solve a lot of problems on a daily basis, like calculating how much attendance we have, how many classes we can bunk. You calculate your attendance, or like calculating how many modules you can skip so that you still pass the exam. All these sort problems that we engineers solve on a daily basis or something. So, and to solve these problems, you need to know what are algorithms. Okay, and that is the first topic. So, what is an algorithm? An algorithm is a word used by programmers when, oh, okay, wait, wrong source. Who even made these slides? Okay, this is what the other definition. No, don't use that. An algorithm is a finite sequence of instructions to solve a problem step by step. Okay, so simple as this. It's just a sequence of instructions to solve a problem step by step. Now think of it as cooking. So in cooking, most of you here may know cooking. Now I know cooking. I make Chinese dishes like Maggi. So in when you cook, you have a recipe and you just follow the recipe, which is basically a set of instructions, and you get your output. Okay, you add in ingredients, you follow the recipe, and you get an desired output, which is the dish that you cook. So similarly, that is what is an algorithm, just a set of instructions to solve a problem step by step. Okay, before I move on, I just want to say one thing. So there are so many people in this audience who are like very beginner in this entire thing, and then there are people who are who may already know all these topics about algorithms. So this all is very basic thing, and we have more interesting stuff coming up like time complexity and all that. So this is at a very basic level. So just wait. If you know all these, just wait till you get to that topic, because that will be more interesting. Yeah. So let's. Okay, how is an algorithm different from program? So an algorithm is like for designing, while a program is the implementation. Algorithm is done before you write a program. It's like the design, and then programming is implementation. An algorithm can be written in any language. There is, you can write it in any language. While program has specific programming languages like C, C++, Python, whatever language that you may have heard. And an algorithm is independent of the machine. So when you write algorithms, it's not depending on the machine. While programs, depending on the programming language, it depends on the hardware and what software you use. All these, it depends. An algorithm is used for analysis, while program is used for testing. Okay, so that's a difference from an algorithm and a program. Okay, let's see some examples of algorithms. Find my pen. Okay. So when you write an algorithm, let's say an algorithm to sum of two numbers. Okay, sum of two numbers. I believe my screen is visible and you can see what I'm writing. Put a random emoji in the chat if you can see what I'm writing. Okay. Yeah, fantastic emojis. Okay. So an algorithm for finding a sum of two numbers, how would it look like? So when you write algorithm, you can write it like this. You can write step 1, and the first step is start. Okay, you have to start, and then step 2. So you need two numbers. So you need to read them, and we store these numbers in variables. Okay, in programming we use variables. So we write read a comma b. Two numbers a and b. I'm denoting these two numbers by a and b. So I want to print a plus b. Okay, I want to calculate a plus b and print the value. So I'm writing an algorithm for that. Okay, and in step 3, what do? We have a variable called sum, which I'm using, which I say it as sum is equal to a plus b. Sum, the value that we calculate a plus b is stored in the variable sum. And then in step 4, we just print it, print sum. Okay, and step 5 end. This is an algorithm for finding the sum of two numbers. Okay, now these print sum, I write it like this. You can also write it like print sum, just like this. There is no specific syntax and all for an algorithm, but you just need to follow some rules, like you have the start and end. But apart from that, there is no specific rules that you have to follow. Here, instead of read AB, I can give input AB, anything like that. So yeah, this is an algorithm for finding a sum of two numbers. I hope this is clear. So can all of you write an algorithm for finding the largest of two numbers? Just like this. You can, okay, typing it in the chat. Okay, no need to write this step one, just write these things. And if you can, at least few of you type it in the chat, largest of two numbers. Algorithm for that, I'll wait for 2 minutes. Yeah, you can just directly write the algorithm. Okay, we read AB. Let me clear the screen. Okay. Now just okay, yeah, we've got some good answers. If A greater than B, print A else B. Yes, very good. That's correct. Input AB, compare and find largest, print largest. Okay. Start AB, compare AB. If AB. Okay, I will write the answer. Most of you gave correct answers. When you say compare AB, I think we can be more specific, like you write if statement for comparison so that it's more specific. So yeah, step one, or you can put it as step 0 also, start. And then step 1, read AB, two numbers. Step 2 is, okay, if I'm using an if statement. This is an if, okay, before I think we had given some resources yesterday or something for going through the basics of programming. So I'm assuming all of you know basics, at least, like what are if statements, what are loops and all. So with that assumption, I'm moving ahead. So this is an if statement. It basically compares two values. So if A greater than B, then we can print A. And in the next step, okay, I'll write step 3 then, else we print B. Okay, this is for printing the largest of two numbers, and then end. Step 4. Yeah, so this is an algorithm for largest of two numbers. I hope this is clear. And yeah, all of you gave answers, that's correct. Very good. And thanks for keeping it active. Okay, so I hope this thing about algorithms is clear. If it's clear, put a thumbs up. About what an algorithm is and how do you write an algorithm. This is the basic algorithm. Okay. Yeah. Okay. Next up, we have pseudocode. Okay. So what is a pseudocode? Pseudocode is like something I would say is in between an algorithm and a program, or an algorithm and a code. So the thing about algorithms is that at each step you're writing step 0, step 1, step 2 and all that. So our ultimate aim is basically to convert this algorithm into a working program. So it is better that we have it as similar to a programming language, not in any programming language, but similar syntax. So that is what is a pseudocode. Okay, pseudocode is also, it doesn't have any specific syntax, but it is written similar to a program rather than an algorithm. So I will show you some examples. Okay, so the same thing about reading or okay, sum of two numbers. There, when we write pseudocode, we don't need to write start, stop, or step or anything. We can just write it similar to code. So I can write it as input A comma B, and then sum is equal to A plus B, and print sum like this. Print sum. So this is a pseudocode. Here we write sum equal to A plus B because now to convert this into a program is pretty easy, right? For you can just replace this statement. If it's Python, you replace it with int of input, or if it is C, you just replace this with scanf. And if it is C++, you use cin. Okay, and this statement works in all programming languages. And you just have to add a semicolon for C++, otherwise it will start cursing at you. And then print sum, this works in Python. So yeah, the basic idea is that you make it similar to programming, similar to the program. So that is what is a pseudocode. Okay, I hope what a pseudocode is clear. So let us see an example of a pseudocode. Let's say you have a jar. Okay, I think this is a jar and it contains a lot of balls. And we need to count the number of balls. So can you type a pseudocode to count the number of balls in the jar? Just okay, wait, let me give, I'll do this because I haven't told you about loops. So to count this, so wait, let's just, okay. Count balls in a jar, okay. Okay. So when we write pseudocode, we are making it similar to a code. So initially, I'm going to have a variable to store the count of, to store the result, which is the count. So, and initially the count is 0. Okay, then I have to, how do we do this? So imagine in real life, how do you do it? For, you just take each ball and count it, right? So for that in programming, we use a loop. So I'm going to use a loop for ball in jar. Okay, this is when we write pseudocode, we can write it similar to any programming language. So in this case, it will look similar to Python, or we can write it similar to C++ or C also, that I'll show you. So for ball in jar, all we do is we increment the count by 1. Okay, and then we print the count. Okay, so this is the pseudocode for finding the number of balls in the jar. Now we can also write it like this: count equal to 0, and for I equal to 0, I less than, say there are, the size of the jar is n, so I less than n, and I plus plus. This is looking similar to the C or C++ or Java loops that we have. This is how a loop will look like in C, C++, or Java. And we'll store these balls in, I mean, the jar as an array. So I will put count equal to, okay, we just need the count. Okay, count plus 1 and print count. Okay, this is also right. So pseudocode, you don't have any specific rules, but we just write it similar to the code. Okay, is that clear? So can you write the pseudocode for finding sum of elements in an array? Are people still here? Type something. Just write the pseudocode for finding sum of elements in an array. And array, okay. Array. Array is basically like a data structure. It's for storing elements. People, I think most of you would know what an array is. So if I have an array, say A, I want to find the sum of elements A, and it has a size of n. There are n elements and array A. Can you please type the pseudocode for this, for finding the sum of element in an array? Yeah, good. So very good. It's correct. Keep it coming. All those people, if there's people here who are lazy, I mean, who are shy to type in the chat, in Zoom, you can change your name. So put it something funny and then type it if you want to. And it doesn't matter if your answer is right or wrong. But I would like to have a lot of responses so that it's interactive. Yeah, okay, cool, very good, very good. Sure. Count is 0 for a, yeah. Okay, So all of you, I believe, have an idea of what is pseudocode, because by looking at this chat, I can see that all of you are typing it correctly. So it's like this. Initially, you use a variable for sum. I'm going to initialize it as 0. And for, I'm going to use a loop. So for I equal to 0, I less than, here I have n, I plus plus, sum is equal to sum plus a of I, where a of I, this is how we access elements in an array through the index and print the sum. This is one way to write pseudocode, which is similar to C, or like most of you have given here, you can write it like this for I in array A. This is like Python, sum plus equal to I. This also works, and print I. So all these are correct. Okay, so very good, all of you. And I think what a pseudocode it is clear, right? What is an algorithm? How is it different from a pseudocode, and what is a pseudocode? Why are we using a pseudocode? Okay, so throughout the rest of the session, we will be dealing with pseudocode. Okay, there is no much code involved, as I told before. It's a theoretical session. So, but we have problems that we'll solve using time for finding time complexity. So throughout the rest of the session, I'm going to be using pseudocode. So are you guys all cool with that? You understood pseudocode? Type anything in the chat. If you have any doubts, feel free to type it in the chat. I will address it, because before we need to move forward, I need to make sure that all of you know what is a pseudocode. Okay, cool. If you have doubts, do ask. No, I didn't. Okay, can you specify what part of this do you not understand? It's basically like a code. You just write code. Similar to a code. So initialize sum as 0. This is, so our task is to find sum of elements in an array. So initially I'm using a variable called sum initialized to 0. And then I'm looping through the elements in an array and adding that value to the sum. So if maybe I can show you with an example. Say my array is 10, 20, 15, 4 and 5. What happens here is initially sum is 0, and then your I is here. So at the first step, the I is added to the sum. So sum becomes 10, and then it becomes 20. Sorry, 10 plus 20, so it becomes 30. Then it becomes 45 and 49, and then it becomes 54. So we get the sum. We just iterate through the array and add it. So if you didn't understand it because you don't know what an array is, you'll learn what an array is in the next session actually. But yeah, this is just for an example. Anyway, for the rest of the session, we won't need arrays, don't worry. Okay, so I think we'll continue. So, right. Okay, now we saw what an algorithm is, what pseudocode is, and how to get the output, how to write code. But then we need to make sure that our code is efficient. Okay, so here I have two guys, Andy and Bob. They're totally two different people, not the same person with two different hats. Okay, and Andy and Bob go to a same class, and their teacher gives them a question to solve. Okay, to write an algorithm and code it. So Andy comes up with a solution that is 100 lines of code, and it takes 2 milliseconds to run on his computer. Well, Bob writes program that's 10 lines of code and takes 3 seconds. So I want you people to tell me which is better. Whose do you think is better? Bob, Andy, Bob, Andy, Bob, 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 Bob. 3 seconds and 2 milliseconds. Okay, there's a difference in the units also. A lot of people say Andy. Now everyone's saying Andy because I said 2 milliseconds. But Bob's code is only 10 lines. Would that matter? Vishruth, hey. Okay, Sharath. Andy? No one. Andy, I'll just, okay, everyone, there's more than 200 people here. I expect the chat to be spammed. Less memory usage for Bob code. Okay, very less memory usage. That needn't necessarily be true, but okay, that's a good observation. Both. Who is Bruce Wayne? I believe that's Tom. Andy is rich. Tom, you can't answer. You saw my slides yesterday. I won't accept it. Anyway, okay, let's move on. Okay, so if you said Bob, to all those who said Bob, you're wrong. Okay. And to all those who said Andy, you're also wrong, because Sharath gave the right answer, which is me. Only I am right. And the reason is I didn't tell you anything about Andy and Bob. You don't even know these people. Okay. So Andy has a MacBook Pro and Bob has a potato computer. Okay. This is why Andy's code is faster and Bob's code was slower. Okay, now the point is, okay, even with this information, you can't say one is better than the other, right? Because Andy might have written code in C or something, which is why it is 100 lines, while Bob would have written code in Python and it's 10 lines. Okay, and so that when we measure efficiency, if we just take execution time, it doesn't work, because execution time is, okay, let me see this. Bob, poor Bob, I still support him. Okay, well, that's what I'm saying. So this there is no right answer for this question, and even with this information we can't tell one is better than the other. So my point is that you can't evaluate things just based on execution time. Okay, so people may think, okay, you want to see which program is better or which is faster. Let me just run it and see. Okay, mine runs faster, yours is slower, so my program must be better. Okay, that doesn't work that way, because this runtime is dependent on machine. And also when we deal with programming, we deal with a large amount of input. Okay, in practical cases, the input is very large. So think about data of, say, Facebook or Instagram. All the users, there are a billion users, so the data there is too large that you execute it and test it each time. So we need to be able to find a way to evaluate the efficiency of our algorithm before we test it. Okay, so that is what brings us to time complexity. Okay, it also depends. Yeah, that's what. So the time, execution time as such, it depends on the language. So my point is that when we measure efficiency, we can't take execution time and use it as a factor. So to measure efficiency, we have efficiency of an algorithm. We basically use two things. One is time complexity and the other one is space complexity. And then there are some other factors also, but mainly these two, time complexity and space complexity. And during this session, we'll be learning what is time complexity. Okay, so time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of size of input. So instead of taking the absolute time, that is the exact time in seconds or anything, we just take it relative to the input. Like how is it depending on the input? Okay, so let's see an example for that. Okay, here I have some boxes. Okay, I have 5 boxes. Oh, and that's Cubo on the right bottom. That is Cubo, the mascot of TLE MEC. And the guy on the left, I don't know, can you give me a name for the guy on the left? Just give me any name. Sharath. Okay, I'll put it as Sharath. Okay, the first name was, okay, anyway. Okay, so yeah, here we have 5 boxes, and one of these boxes contain what does it contain? A cake or something. Okay, one of these boxes has a cake in it. Now you have to find which box has the cake. Can you write a pseudocode for that to find which box has a cake? Okay, that looks similar to me. Interesting. Okay, write a pseudocode for finding 1/4 one. That's a nice guess, but it's not the fourth because you said it's fourth. Till yesterday it was fourth, but now that you said it, I'm changing it. It's not fourth. Should have named it TLE. Oh, then we'd have TLE and the mascot of TLE in one place. Okay, for I in boxes, if I equal kick, print I break. Okay, that works. Okay. So, okay, that's the correct answer. Okay, I will start writing stuff. Oh God, what is this? Excuse me, I clicked something and that happened. Why do I have a timer on my screen? What is this? Okay, never mind. I'm sorry for that. Okay. So here I have 5 boxes. And let's say Sharath. This was Sharath, right? I'm going to put it as Sharath. And this is Cubo. Okay. Sharath take 2 seconds to search a box, while Cubo takes only 1 second to search a box. And as per all your pseudocode, whatever pseudocode that you gave, it's correct. Like for for I in box, if I is cake, then you print. Okay. Print I and you can break. Okay. So this works, but anyway. Okay. So if I have 5 boxes, I will have like what I'll do is I'll go first check if this box has the cake, and then check if this box has a cake, and so on and so forth. Okay. So if Sharath takes 2 seconds per box and there are 5 boxes, okay, before that, we'll be talking about time complexity. So there are like 3 cases. One is best case, one is average case, and the other is worst case. Okay. What is the best case? Okay. The best case scenario in this case would be if we have the cake in the first box. So we just have to search one box, right? In the best case, the cake is in the first box. Can you tell me what will be the worst case here? If the cake is in the first box, then you just search the first box and you got the cake already. Okay, someone stole the cake. That's actually very good. That's the worst case, because if there is no cake, then you will end up searching all boxes and be sad in the end. So that's worse than the worst case, but anyway. Okay, last box. Yeah, when you have the cake in the last box, that's the worst case. And then the average case is somewhere in the middle. Okay, so whenever we find time complexity, we can use these 3 cases, but most commonly we'll be dealing with the worst case. Probably because programmers are inherently pessimistic. I don't know, maybe because of that. But anyway, we'll be dealing with the worst case because it works for all the other cases also. When we take the worst case scenario, we cover all the other cases. So in the worst case, if there are 5 boxes, then how much time will Sharath take to find the cake? If he takes 2 seconds per box, how much time is Sharath gonna take to find the cake? In the worst case scenario, there are 5 boxes. So can anybody tell how much time Sharath will take? 10. 10 what? I want a unit, people. 10 seconds. I'll give a unit. Okay, 10 seconds. Right? Okay, 10 seconds. Now, if I had 10 boxes, then how much time will Sharath take? 5 seconds is wrong. 12 seconds is also wrong. It's just 10 seconds actually. Yeah, 10 seconds, because you'll see this box takes 2 seconds, 2 seconds, 2 seconds, 2 seconds, 2 seconds, and you take time. So even when you get the cake, you take 2 seconds for that box. So then it takes 10 seconds, and for 5 boxes, and for 10 boxes it takes, no, it's not, it takes 20 seconds. Yeah. See, if there are 10 boxes, it will take 20 seconds, right? Because for each box you take 2 seconds. In the worst case, I'm talking about the worst case, okay, when the cake is in the last box. Yeah, 20 seconds. So okay, so for 5 boxes it took Sharath 10 seconds. For 10 boxes it takes 20 seconds. Okay, if there are n boxes, how many seconds will it take? Oh, okay, I'm so sorry. There are 6 boxes on the screen. How did I miss that? I'm so sorry. I'm so sorry. I meant only 5 boxes. Okay. So that's why many of you gave 12 and 18. I mean 12 seconds. Okay. There's only 5 boxes. Okay. 5 boxes. 5 boxes. Okay. Anyway, if there is n, it will take 2n, right? 2n seconds. So here the time it takes is depending on n, right? It's some function of n, right? In this case, it is 2n. Can you tell for Cubo what will it be? For Cubo, for n boxes, how much time is it going to take? N, right? It is n. So in both these cases, this is what we call as has a time complexity of order of n. Okay, time complexity or big O of n. So this notation is called the big O notation. It is one of the notations that is used to denote time complexity. So you can read it as big O of n or O of n or order of n. Okay, this is one of the notations that we use. So this is what is called a order of n or big O of n time complexity. This basically means that the time it takes is linearly dependent on the input. Okay, it can be n, it can be 2n, it can be 5n, or anything like that. Still, the time complexity is order of n. Okay, because as the number of boxes increases, the time will also increase. Okay, is that clear? Does that make sense? Big O of n or order of n, what the time complexity means. All right. So one more, okay, let's take one more scenario. So Sharath, I think Sharath, let's say Sharath is very lazy. Okay, before he starts counting the boxes, he needs 10 seconds. I don't know, to talk with someone. So, okay, so 10 seconds, and then only he starts counting these, he starts searching these boxes. Okay. Okay, Sharath, you can talk with me after the session, but anyway, you were the one who named yourself, so not my fault. Okay, so now can you tell me how much time will Sharath take for the boxes? There are n boxes, and Sharath initially waits for 10 seconds and then starts searching. It is 10 plus 2n, right? 10 seconds waiting, and then he takes 2 boxes. Okay. 10 plus 2n. Even in this case, we say that the time complexity is of the order of n because these small constant doesn't matter. So it doesn't matter if Sharath waits for 10 seconds or something because this n is usually very large. Sharath has like 1,000,000 boxes which he has to check to find a cake. So nobody cares if he waits for 10 seconds, right? So these constants are ignored and we just take in this value. That is the largest polynomial. Okay, this is a polynomial. So we just take the largest the largest value, which is order of n. So if it is 2n plus 10, it is order of n. If it is say n plus 40, it is also order of n. Okay, is that clear? So we don't actually bother about the exact constants. We only need a way by which we can see how it varies according to the input. So in this case, it varies linearly. Okay, which is order of n. We'll see other time complexities. It will become more clearer when you see more time complexities. Okay, is this clear? So can you tell me if the function is say 5n plus 23, what is the time complexity? What is the time complexity of this function? N, right? It's order of n. Okay, cool. Same. Okay. So that is what is order of n time complexity. Okay, next input. Okay, yeah. So this is a graph basically. So like how the okay, so here this is y is equal to 2x and this is y is equal to x. Both these cases you can see that it increases linearly, right? So this is order of n. This is how a graph of order of n looks like. Okay, and as I said before, the constant doesn't matter. So we just take the time complexity as order of n, and the x-axis is input size. So as input increases, this increases linearly. So if there are 4,000 boxes, then Cubo will take 4,000 units of time. Okay, so yeah, this is just a graph. We'll see more graphs later. Okay, right. Okay. Okay, we have a new guy here. This is Tallow. I believe it's Tallow. If I'm wrong, someone from TLE correct me. Sorry. Yeah. So this is Sharath, Tallow, and Cubo. And again, we just have 5 boxes here. I'm sorry for the 6th box. Anyway, so Tallow already knows which box the cake is. Okay, Tallow is like, he knows which box the cake is. He can just tell it. He knows which box the cake is in. So all these 2 people have to do is to go and ask Tallow which box the cake is, and Tallow will tell. But Tallow and Cubo are friends. So Tallow takes 1 second to tell the answer to Cubo, while Tallow and Sharath are not so good friends yet. So he takes 5 seconds for Sharath just to tell the answer. Okay. So I hope the scenario is clear. So Tallow already knows which box the cake is in, and he takes 5 seconds for Sharath while 1 second for Cubo. Okay. So if there are 5 boxes, what is the time taken for Sharath to find the cake? Hello. 5 boxes. How much time will Sharath take to find the cake? 5 seconds, I believe. Right? 5 seconds. Okay. Now, if there are, say, how much time? Okay, Tallow takes 5. No, Tallow already knows which box it is in. He knows it. He doesn't have to do any calculation or anything. He knows which box the cake is in. But for Sharath, he takes 5 seconds to tell the answer, while for Cubo, he takes 1 second to tell the answer. Okay. So Sharath goes and asks Tallow, hey Tallow, which box the cake is in, and Tallow tells it in 5 seconds. So all those who said 5 seconds, you got it right. Okay, now if there were 10 boxes, how much time will Tallow take? No. This we don't. Okay, see, unlike the earlier case, these 2 people don't go and count the boxes. Okay, they just go to Tallow and ask him, where is the cake? They don't go count the boxes because Tallow already knows which box the cake is in. Okay, so ignore that the 2 seconds per box is not relevant anymore. Okay, so if for 10 boxes, how much time does Sharath need? 5 seconds, right? And if there were say 10,000 boxes, how much time does Sharath need? Still the 5 seconds that he needs to ask Tallow. Now this is what we call as constant time complexity. Okay, denoted by order of 1. I just made it worse. Okay, order of 1. Okay, 1 here, it doesn't mean that 1 second. Order of 1 means that the time it takes is independent of the size of the input. Okay, the size the number of boxes doesn't matter. All the time it takes is 1. Now 1 doesn't mean 1 second. In this case, it is 5 seconds. So in case of Cubo, it is just 1 second. Now if it takes like 1000 seconds for someone, but it is not dependent on the input, then also we say that the time complexity is order of 1. Okay, it is constant time. This is constant. It is read as constant time. Okay, or the time complexity is a constant. Okay, is that clear? Basically, constant time means the time taken for the algorithm is independent of the input, or is independent of the size. N doesn't the size n doesn't have any relevance. Okay, and it is denoted by order of 1, not order of 0. Order of 0, no, it is denoted as order of 1. This is the way it is. So 0 means there is nothing. We just use order of 1 actually. For and like we don't say, if it takes 5 seconds, we don't say O of 5. We just say it as O of 1. Okay, order of 1. I hope that's clear. Yes. Okay. So that is, so we saw order of n and order of 1. Now next, let's see the next one. Yeah. So this is a graph for these things. So Sharath takes 5 seconds. So irrespective of the input size, the time is a constant, right? And even in the case of Cubo, irrespective of the input size, the time is constant. So this is how a graph of order of 1 looks like. Okay. Okay. Now let's add some twist. So again, there is just, okay, again, there's just 5 boxes. I'm so sorry. Here, now we have keys. Okay, for each box, there is a key, and we don't know which key belongs to which box. So now what you have to do is, for each box, you test one of these keys, and then you open the box and see if it has cake. Okay, and you repeat the process, and we don't know which key. Okay, one key may open multiple boxes. So if this key opens this box, then even when counting the rest, you count all the keys. You take this key also. Okay, is that clear? Like, for each box, you have to check all the keys and then only see if the cake is there. Okay, so for the first box, and let's say again, now let's consider Cubo. Okay, this Cubo takes 1 second for selecting a key, and let the time taken for opening the box be negligible. So for the first box, how much time is Cubo going to take to find the key? In the worst case, again, we are always talking about the worst case. So for this box, how much time is Cubo going to take? 5 seconds, right? For this box, again, he goes through these 5 keys and it takes 5. Okay, so for 5 boxes, how much time does it take? For all the 5 boxes, worst case, it takes 5 into 5, that is 25 seconds, right? And if there were 10 boxes, then how much time will it be taking? 50. How is it 50 if it's 10 boxes? No, it's not 50. 100, yes, correct, 100. No, not 5 raised to 10. No, 5 boxes is 25. See, 10 boxes, what happens? What happened? Okay, see, for each box, you go through each of these keys. Okay, the number of keys is equal to the number of boxes. Okay, so for 5 boxes, you go through 5 of the keys. So if there were 10 boxes, then for the first box, you will go through all the 10 keys. Okay, and then for the second box, again, you will go through all the 10 keys. And how many boxes are there? There are 10 boxes. So in total, you will do 10 boxes, and for each box takes 10 seconds. So 10 into 10, which is 100, right? And if there were n boxes, then this would take n square time, right? This whole searching process is gonna take n square time, and this is called order of n square. Okay, this has a time complexity of order of n square. Okay, I hope that's clear. Now, if it was Sharat takes 2 seconds to find a key, then you will have to add multiply this by 2. So I think that would work out to be how much? 4n square, I believe. Even this is just order of n square. So whenever we find time complexity, okay, you didn't get this. Okay, I'll just explain again. See, there are 5 boxes, and each box, for opening each box, like there are 5 boxes and 5 keys. Okay, is that much clear? Like 5 boxes and 5 keys, and one of these keys opens a box. You don't know which one. Okay, so, and our objective is simple. We need to find the cake. Okay, it is in one of these 5 boxes. Okay, so for the first box, what do you do? What do you do for the first box? Can and Rose Matthew, I hope I'm pronouncing it correctly. Can you tell what do you do for the first box? Yeah, you try these keys, right? So for the first box, you try the first key. It doesn't work. You try the second one. Okay, we are considering the worst case, as I told. So this also doesn't work. Let's say it's the last key that opens the first box. Okay, this also doesn't work. And then this also doesn't work. And this also doesn't work. And then this works. Okay, so here you would, and let's say Cubo takes 1 second to take a key. Okay, so this process takes 5 seconds, right? Because you need to select each key and try opening. That takes 1 second. Okay, is that clear? Okay, now what you do is, again, you put these keys back how it was, and then go for the second box. Okay, for some reason, let's say you just put the keys back shuffle it and then try for the second one. Okay, and then again in the worst case, you would have to try all the 5 keys before you get, because as I said before, sometimes the keys can repeat. Okay, so this also would take 5 seconds, right? Is that clear? This box also needs 5 seconds. Each box needs 5 seconds, because you need to try all the keys for this box also, like you did for the first one. Okay, so similarly, this box will also take 5 seconds in the worst case. Okay, you try all the keys, and all the boxes take 5 seconds, and there are 5 boxes. So in total, yeah, same key may or may not unlock. That depends. Like there may be keys that unlock. So we are dealing with the worst case. Okay, so let's say that same key can unlock multiple boxes, and no, there is no master key. Life is not that simple for right now, but we will make things simpler later on. Anyway, so 5 seconds. This will take 5 into 5, 25 seconds. Okay, and if there were 10 boxes, then you need to do the process again for 10. There will be 10 keys. So then for each box, it will take 10 seconds, and that multiplied by the number of boxes will give the total time, right? 100 seconds. So if there were n boxes, then it takes n square seconds. Okay, yeah. So this is what is order of n square. Okay, this program algorithm, 10 box, not 5. No, 10. The number of box has the number of keys. Okay, wow. We have a pseudocode for this by Parthiv. And try opening j+1 for I in key for j in box. Okay, you're trying the keys for the boxes. For each key you're trying, yeah, that should work. Because for this key, you're trying the box. Okay, what you're doing is the reverse thing. So for you're iterating through the keys first and then the boxes. Yeah, that will work actually. But if you can swap the box and keys, then it would make sense, like whatever I did. But yeah, that pseudocode is correct. Very good coming up with that. Okay, just because you came up with that without I asking, I'll give you a sticker. So Parthiv, Anil, can you tell me which class you're in? I believe you're from MEC. If so, can you tell which class you're from? What didn't you get? CSB first year? Okay, cool. Okay. When we meet in college, I'll give you. Anyway, so this is clear, right? Yep. In the worst case, yeah, 5th key opens. And also one thing I said is that we shuffle these keys at each step. So the 5th key may not be always the 5th key. But yeah, your point makes sense. In the worst case, the 5th key opens all the boxes. Anyway, so this takes and oh. Yeah, sure, Sharath. I'll give you a sticker, don't worry. I'll give you a sticker on WhatsApp. Okay. Anyway, here we have n square. It takes n square time. Okay, now I hope that is clear. So if the function was say f of n is equal to 2n square, then also the time complexity is order of n square. Okay, we are just bothered about the we are not bothered about constants. Whenever we find time complexity, to keep things simple, we don't bother about these specific constants. And you'll see why we don't take these constants in the end, because for large values, they don't really make any sense. As in, they don't really affect our answer. So that's why we don't consider the constants. So if it is 2n square, it is just order of n square. So if I have, say, f of n is equal to 10 plus 4n square. Can you tell me what is the time complexity? Anybody? Again, it is order of n square. Okay, we just select the maximum, the largest degree thing. Okay, order of n square, because these small constants don't matter when we find the time complexity. So this is order of n square. Okay, so far we have seen order of n, order of 1, and order of n square. Okay, these 3 time complexities. We'll see some more. Okay, let's proceed. Okay. Next is about logarithms. Okay, we have logarithmic time complexity. Okay, so I believe most of you here would know what logarithm is. You would have learned it in your school or something, but that will be log to the base 10. In computer, we deal with log to the base 2. Okay, this in computer science, whenever we refer to log, it is always to the base 2 because this 2 comes from binary. Okay, computers have 0 or 1. So log is always to the base 2 in computer. Now, if I have say 2 raised to k is n, then k is log to the base 2 of n. Okay, this is what is logarithms. Okay, so I'll give you an example. Say if I have 2 cube as 8, then log to the base 2 of 8 is 3. Okay, you need this log n because we'll see why. We'll see algorithms that have logarithmic complexity. So for that, I'm just telling what log to the base 2 is. So if I have, so can you tell me what is log 2 to the base, log of 16 to the base 2? Yeah, it's 4. Because 2 raised to, you just, to find log of something, you just see 2 raised to what power gives that number. Okay, so it is 4. Right, 2 raised to 4 is 16. Okay, so that is about logarithms. Now we have a okay. Imagine you have a dictionary or you have an encyclopedia. Okay, or a dictionary, and you need to find a word that starts with say P. Okay, a word that starts with P. What do? You just open a page somewhere in the middle. Okay, and okay. Okay. Before that, I just like to remind you something. So this session has certificates. Like if you attend all of these sessions, you'll get certificates. So please fill in the registration form to get the certificate so that we know that the registration form, the link, someone from the TC or TLE, please put it in the chat. If you haven't registered in that link, please go register there so that we know that you have registered for this. Okay, so someone from the TC or TLE, please put the link in the chat for the registration form. Okay, and also regarding the certificates, I'll tell it in the end. There's one more thing. So please wait till the end of the session and before, don't leave in between. Okay, anyway, coming back to this example. So if I have a dictionary and I want a word that starts with the letter P, what do? I just go open it somewhere in the middle. Okay, and then let's say the letter I got, the word starting was N. Okay, so what do? I know that P comes to the right of N, right? So I just open a page somewhere to the right of N, and then if I get say R, a word that starts with R, what do? I go, I know that P comes to the left of R, and then I open a few pages on the left and I get P, right? This kind of searching, so this is actually, what are we doing? We are searching for a word, right? This kind of searching is called binary search. Okay, this is a pretty much important thing, very important thing in computer science. Any person who knows computer science should know what is binary search. Okay, this is basically what is binary search. So you are dividing your search area in half. Okay, and it works only on sorted items. It only works on sorted items or sorted lists. So in this case, a dictionary or this is a dictionary or encyclopedia, so it is sorted. Okay, and it only works on sorted things. We use binary search. So how it works is, if I have a list, say or an array, we have a list or an array. What we do is we take the middle value. Okay, we take the middle value and we are searching for a target. Okay, we compare the target with the middle value. Okay, in this case, the word that I needed was P, right? And I initially opened a page somewhere in the middle of the alphabet, that is M. And then I compared P with M. So I know that P comes to the right side of M. So is there any point in searching the left side? No, right? Because we know that P is on the right of N. So I don't need to search on the left. So what I do is I now make this, my search area becomes reduced by half. Okay, and I just search on this side. So now again, in this case, we take the half. Again, we take the half and compare the value, okay, whatever it is. And then finally, we will have just a size of 1, which is the answer that we need. Okay, our search area at each step reduces by half. Okay, is that concept clear? The part where search area reduces by half at each step. If it's clear, put any random emoji in the chat. Yes, clear. Okay, good. Right. Okay, if there is anyone who has any doubts anywhere in this part, do ask in between, because I'm assuming all of you are following this. And if you have any doubts, please ask and I can explain. Because if you're not following, yeah, I hope all of you are following this and it's not too complicated. Okay, I hope you can understand. Okay, how is it half? See, initially our sizes, okay, I'll explain again. See, we have a, let's say this is the all the alphabets, okay, and I'm looking for a word that starts with P. Okay, so initially what we do is we compare the algorithm. I'm talking about the algorithm now. When we as humans look for a word in a dictionary, we know where it is approximately, we do all that, but this is what a computer does. So it goes and it checks this half. Okay, it goes to the half. I mean, it takes the middle element of the entire thing. So in the alphabet, let's say the middle is something N or M. Okay, and I am looking for a word that starts with P. So what do? Do I need to search the left? Do I need to go search the, here it is from A to N and here it's from N to the Z. Okay, so I know that it comes on the end, this side. So now I just have to search on this side. So initially when I had 26 letters, now I just have half of that, which I have to search, right? What if the number is odd and element is exactly in between? See, when in the algorithm we use integer division, right? So when we take n by 2, we will get one of the element as the middle element. Okay, the total number of elements needn't be even. Like if we have 5 elements, we can take the middle as either 2 or 3. It doesn't matter. Okay, one of these elements we can take it as middle, and then the algorithm will work. Okay, that when you write the algorithm, you can see it will work even if the element is odd, or I mean number of elements needn't necessarily be even. Okay, that I'm not going deep into the algorithm or the pseudocode, because if I do that, that's a bit complicated for right now. I mean, at a beginner level. So I just want to explain the logarithmic time complexity. But yeah, the algorithm works for odd numbers as well. Okay, you can either take it as 2 or 3. So when usually it is taken as 2, because you just find mid as integer division. So L plus R by 2, and the value integers, if it is 2.5, it becomes 2. Okay, so yeah. Okay, so is the part where it is searching half, I mean the area becomes half clear, and rows? Okay, so okay, the area becomes half right now. So we need, let's see what's the time complexity in this case. So here, let's say the steps, okay, the number of steps required for searching and the size. Okay, initially, let's say I have n elements. Okay, at the initial step, at the 0th step, the size is n. Okay, at the first step, what happens to the size? It becomes n by 2, right? The size becomes half. At the second step, what happens to the size? Can anyone say? Second step, it becomes n by 4, right? N by 2 by 2, which is n by 4, and I'm writing n by 4 as n by 2 square. Okay. Third step, it becomes n by 2 cube. Okay. So at a step k, it becomes n by 2 raised to k. Okay. At any step k, let's assume it becomes n by 2 raised to k. Now, when does the search get over? When the size becomes 1. That is when there's only one element left, it becomes, the algorithm completes execution. So when n by 2 raised to k is 1, it stops, which means 2 raised to k is n, or what is k? We saw that k is log of n. Okay. So if for n elements, we take k steps, right? And what is k? K is log n. And this is why the time complexity of binary search is log n. Okay, it is the order of log n, because for n elements you're just taking k steps, and what is k? K is log n. So I'll show you this with an example. So if I have say 8 elements, okay, at the first step at 0 the size is 8, then the next step the size becomes 4, then it becomes 2, and finally it becomes 1. So how many steps did we take? We just took 3 steps, right, to find the answer. At each step it gets divided by 2. So 3 is nothing but log of 8, right? So this is the logarithmic time complexity, and the time complexity of binary search is log n. Okay, this is how the time complexity of binary search is log n. And this is a very important thing that you should know. Time complexity of binary search is log n. Okay, I hope that's clear. If yes, then we can move on. Yes. Put anything. Okay, great. One second. Oh, okay. Oh God, it's 7:20 already. Okay, we need to hurry up. Calculating. Okay, the next is calculating time complexities. We use frequency count method. So far we saw real life examples. So now let's see programming. We need to find the time complexity of code, right? So we will see how to calculate time complexity of code. Okay. And we use a method called frequency count. So, okay. Okay. So there are some rules for that. It's basically whatever we have seen. I'm so sorry. It's basically whatever we have seen so far. So the first thing is simple statements take constant time. Okay. What I mean is simple statements like say sum equal to 0. Okay. Or simple mathematics like sum equal to a plus b, or say print hello world, or print hi. All these take constant amount of time, or have a time complexity of order of 1, because there is no n and all here. It doesn't depend on the size of input. So these statements take constant time. Okay. The next rule is whenever we find the function, we ignore the constants. This also we saw, right? If I have f of n is say 2n, we don't take this value 2. It is just order of n. Okay, and the third rule is we only take we neglect the smaller terms, neglect lower powers or lower degree terms. Okay. Okay. So if I have say f of n is equal to 4n square plus 3n plus 2, then the time complexity in this case is order of n square. We just consider the term with the highest degree. Okay, these smaller terms don't matter and the constant doesn't matter. Okay, so quickly tell me what's the time complexity of f of n is equal to 4n cube plus 2 log n. What's the time complexity of this? Using these three rules, it's O of n cube, right? Okay, cool. So this is how, so first what we do is we find the function, and then using that we can find the time complexity. Okay, now let's take an example of a loop. Okay, so initial, I'll write a code, s is 0, and I'm gonna write a loop. Okay, a while loop, while I, okay, while I is less than n. Okay, I also we put I is 0, not s. I is 0, while I is less than n, I equal to I plus 1. Okay, we need to find the time complexity of this code. How do we do it? So what we do is frequency count method. We take the count of each of these terms and then add it up. So then we get the function, and then using that we'll find the time complexity. So this code takes 1 unit of time, right? As I said before, it's constant. Okay, now the loop, the statement inside the loop runs for n time. Okay, I hope that part is clear, because this loop goes from 0 to n. So this statement is run n times. Okay, and this condition is checked n plus 1 times, because in the last time also, so if I have say n is say 5, then in the first case 0 less than 5 is checked, then 1 less than 5, 2 less than 5, 3 less than 5, 4 less than 5, and 5 less than 5 is also checked. Okay, at this point it exits out of the loop. So this takes n plus 1 time. Okay, so here if I have 5, 1, 2, 3, 4, 5, 6, there are 6 comparisons being made. So this particular statement takes n plus 1 time. So to find the function, you just add these 3. So what do you get? 1, 2 plus 2n, right? So can you tell me what's the time complexity? It's order of n. Okay, order of n. Okay, good. So that's how we do it. We just find the time complexity, take for individual statements and then add it up. You get a function and then use those rules that I mentioned earlier to find the time complexity. Okay, so let's take an example. Find the time complexity of this code, this function. You can type your answers in the chat. Because we are a bit short of time, I will do this. So this statement, you can type your answers. Yeah, and okay. So this takes 1. Now this is a for loop. Okay, so this I equal to 0 takes 1 time. And I less, okay, the contents inside the loop take n time. And this I plus plus also takes n time. This condition is taking n plus 1 time, because similar to the while loop, we'll be checking it n plus 1 times. Okay, so this takes n plus 1 time. And so these 3 statements of this loop, it takes 1 plus n plus 1 plus n time. Now you can take these terms. Okay, we'll take all the terms then. Okay, so just add all the, and the return statement takes 1 time. So just add all these up and see what you get. 1, 2, 3, 4, 4 plus 3n, right? So this is order of n. Now when you calculate time complexity, there is one more trick or one more shortcut. So you can just take the time complexity of this whole thing as n plus 1 itself. Okay, the other two small, I mean the other n and 1 don't matter. You take this as n plus 1, this as n, and then this as 1 and 1, and you get a function, and you can say that this is order of n. Okay, is this clear? If you have any doubts, you ask. So we are not bothered about these small constants and all. That's why I said you can take it as n plus 1, or you can take it as 2n plus 2, which we saw earlier. So ultimately, we just need to find the time complexity, and this is order of n. Okay, so I hope that is clear. Okay, do you guys need a break? Wait, what's the time? 7:30. We were supposed to stop at 7:30, so I think just take a 2-minute break and get back. We just have, okay, after the rest of the session is purely problems based on whatever we saw. There are some really nice problems like these that I showed. So it's purely some problems that to find the time complexity, and then there's the last comparing time complexities that I'll show. Okay. So just 2 minutes. Okay. Okay, I think we can resume. Okay, are you people still here? Please don't leave, because there's something at the end I'll tell you about certificates and stuff. So I hope all of you are here. Okay. Okay. This is just practice questions. Quickly type the answer in the chat. All of these five, this is 5 questions, but all of them have the same time complexity. Find the answer. Just type the answer in the chat. All of these 5 statements, what's the time complexity? 1. It's not n, it's 1. 1, right? Because these are simple statements. All of these statements are very simple statements. So they have a time complexity of 1. Okay, this is not one single program, it's five different statements. Okay, 1. Okay, next. This one. If any of you need explanation to any question, do tell. I will explain the hard questions anyway, but this is something we already seen. So it is n. Okay, this one. Okay, ignore those texts. I don't know, someone who's so jobless made these slides. So anyway, this is also n, right? Because in the other case, we went from 0 to n. Here you go from n to 0. Both cases you take n steps. So the time complexity is order of n. Okay. Okay, this one. This is an interesting one. Try it out. N square. Yes, very good. If n square, I hope all of you know. Okay, let me just quickly tell you how it's n square. So this loop executes n plus 1 time. Okay, and this entire thing inside the loop, we know that it executes n times because of this outer loop. Okay, this is what is called a nested loop. Okay, and then inside this loop, this executes n plus 1 time, and this print statements execute n times. Okay, so here we have n plus 1, and then here this loop, this whole content executes n plus 1 time. So this becomes n into n plus 1, and this becomes n into n. So when you add these up, you get a function having a degree of n square. So the answer is order of n square. Okay. It is n square, not n into j, because we find the answer in terms of n, not other constants. Whenever we find time complexity, it is in terms of the size of input, okay, which in this case is n. Okay, so it is n square, not n into j. Please note that it is n square. Okay, moving on. Okay, this one. Okay, also one more thing. The session was supposed to end at 7:30, but we ended at 8. I'm so sorry for a bit delay. Okay, just a few more questions and we'll wrap it up pretty soon. Okay, this is also n square. I don't think this needs an explanation. It's similar to the other one. In place of a for loop, I use the while loop. Okay, if you need explanation, do tell. Otherwise, I'm going to move to the next question. Okay, this one. This is something I've already seen, but try to do this. I will explain this, don't worry, but try to do this. Something I've already seen. Okay, log n. Some people say n, the others are saying log n, some are saying n. Log n to the base 2. Yeah, in computer, when you say log n, it is understood that it's the base 2. So yeah, that's okay. Log n. Okay, I'll explain this. So all those who said log n, you're correct. The answer is log n. Okay, answer is log n, because see this, at each point the size is reduced by 2, right? So at each step, as I said before, like okay, we take steps and then the size. Initially it is n, and then as you go, it becomes reduced by 2 and so on. And at some step k, it becomes greater. It becomes n by 2 raised to k. Okay, and this loop stops when size is equal to 0. I mean, when as long as size is greater than 0, it continues. So when size equal to size by 2, 10 by 2. Okay, this should be not 0, it should be 1. Okay, I'm so sorry. It should be 1, not 0. Okay, when size is 1, this stops execution. So n by 2 raised to k is equal to 1, or k is equal to log n. This is the same thing that we saw when I told binary search. I just wrote it in a loop. Okay, that same logic here. So this code has a time complexity of order of log n. Okay, all right. Will it work if, yeah, the size gets divided by 2. It is an int only. This will work. Integer division applies. Okay, next. Okay, no need this question. Try this. This is a very simple question. And okay, so here I'll just explain one quick point. So this loop takes n time and this loop takes n time. So n plus n is order of n itself. Okay, 2n, we get it as 2n, order of n, or never mind. This is order of n and this is order of n. So order of n plus order of n is still order of n. Okay, we don't say 2 times order of n, it is just order of n. Okay, on the other hand, if I had something like order of n square plus order of n, then it would be the time complexity would be order of n square. We just take the largest term with the largest degree. Okay, so yeah, this is order of n, correct. Okay, next question. Okay, okay, this, 1 second. Okay, we'll try this question. Try this question. Here, if you notice, the I value gets multiplied by 2. It is log n. Okay, log n. 1 second. Some people are saying n, some people are saying log n. Okay, so I'll explain this. See. 1 second. Okay. See, here it is log n. The answer is log n. All those who said log n, you're correct. It is not n, because see, at each step I gets multiplied by 2. Okay, so initially I is 1, then I becomes okay, we'll trace it. I becomes, initially it is 1, then it becomes 2, then it becomes 4. So it increases as a power. Okay, it goes like it increases as a power of 2. So at some step I becomes 2 raised to k. Let us say at step here 1, 2, 3. At a step k, I becomes 2 raised to k. Okay, and when does this stop execution? Here I is less than n. So when I is equal to n, when I reaches n, this stops. Which means when 2 raised to k is equal to n, this program stops. Right? And so what is k? K is log n. That is why this code has a time complexity of log n, because the number of steps, or the I, this is the number of steps is k, and k is log n. Okay, so this one is log n. What if, okay, we have an interesting question. What if it is I star 3? Can anyone give me the answer if I was I star 3? Yes, very good. It is log to the base 3. Here it was log to the base 2. If it was I equal to I star 3, then this would become 3 raised to k. Okay, it will go like 1, 3, and it will go in powers of 3. So this will become 3 raised to k, and the time complexity would be order of log to the base 3 of n. Okay, so that was a very interesting thing. Okay, anyway. Okay, so this one. What if I equal to 2? I'm not sure what you meant. because that's supposed to be an increment. Anyway, try this question. I'll get your doubt in the end because we're a bit short of time. I'll get all your doubts at the end. So try this question, similar to the last one, but a bit. There's one more thing that you have to take care of. No, none of your answers are apparently correct. N log n. Okay. 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 N log n. Any more answers? Okay. Log n, is that log n square? N to the log n. Okay. Okay. Log of n square. Okay. Interesting. So I would suggest you have a book and a pen and just work this out. Then you know, instead of just guessing it. I wanted to mention this at the beginning, but I forgot. So it would be nice if you could have a book and work this out. Just the way we did the previous thing. Okay, I'll just discuss, I guess. Any more answers? If you have any answers, do tell. Log n raised to n. Okay, we have a lot of different answers. Interesting. Okay, so the answer is n log n. All those who said n log n, you're correct. I'll explain how is it n log n. See, this is n plus 1. Okay, and okay, that is n. Now take this inner loop. We just consider this inner loop is same as what we saw before, right? This inner loop is log n. Okay, the inner loop alone takes log n because we saw it in the earlier example. Same thing, j, except in case of I, it is j, and the loop is pretty much the same. So this is log n, okay? And the entire contents of this loop is executed n times, right? Because of this outer loop. So this becomes log n times n, okay? Log n times n, not log of n into n, it is log n times n, okay? And this is n plus 1. So this is n plus 1 plus n log n. And among these, n log n is the dominating term, okay? So, okay, okay, log n raised to n, okay, right. But in, okay, I get that, but in compute, I mean, when you discuss time complexities, you just say it as order of n log n, okay? Instead of log of n raised to n, you tell it as n log n. This is the way it is written commonly. And this is again an important time complexity. So sorting algorithms, I'm sure some of you would have heard of sorting algorithms. What are sorting algorithms? All the sorting algorithms that you can find in programming languages, the inbuilt sorting algorithms have a time complexity of n log n. Okay, this is something you should know. You will anyway learn, if you're into computer science, you will learn about sorting algorithms in detail. But just know that the inbuilt functions in all languages, like for example, in Python, you have sort, which sorts the list. And in C++ also using STL, we have sort. So all these sort functions have a time complexity of n log n. Okay, it is n log n. And this code is also n log n. Okay. So I think that's enough of questions. The rest of the questions, I will share my slides, and you can try out the rest of the questions, and if you have doubts, you can ask me. So one thing I just wanted to tell you is regarding, so so far we saw all these time complexities, right? Order of n, order of 1, n square, n log n. We'll see how they are different. Okay. So for that, I have a graph here. Okay, I will just show you quickly. So let's see how y is equal to x. This is order of n. Okay, this is like y is equal to n. I mean, f of n is n. So this is order of n. Okay, this graph. Okay, and I'll show you how this is relating with order of n square. Okay, now we'll just take the positive values. If you look at this, okay, one more thing. The x-axis here is the size of input. Okay, the size of input, and the y-axis is the time taken to run. So what I mean is, if for n, if there are 10 elements, it takes 10 units of time for an algorithm that runs in n time. Okay. And looking at this, see for 10, you can see how much more time an algorithm of n square takes, right? It's 100, right? See the difference. If you see this graph for just 10 elements, the n algorithm takes just 10 units of time, while the n square takes 100 units of time. And the difference only becomes larger as you move with higher values. So for n equal to 100, you can see that an algorithm that runs in order of n just takes 100 units of time. But if I have to find it for n square, see how much more time it takes. See the amount of time, it's so increasing, right? So when you write an algorithm that is order of n square, the time it takes increases quadratically with the input. And this is one of the reasons why you get a TLE. Okay, because if you write an algorithm which is order of n square, then the time it takes for a large input will be increasing quadratically, right? So that and that is not acceptable. So that is why you get a TLE. And so you need to be able to come up with algorithms that are efficient, right? Now let's compare. Okay, we saw n square. Now let's see y equal to log n, log x. See how efficient logarithm is. This is the graph of logarithm. So even for large inputs, the time never goes above 50. Okay, as I increase the input size so much, the time never goes above this value, above a particular value. Okay, so logarithmic complexity is more efficient. Okay, so we saw these three. Okay, now let's see one more. Y equal to a constant, say 7. Okay, now this constant time, obviously for irrespective of the size of input, it takes constant time. So that is order of 1. That is the best complexity there is, because irrespective of the size of input, the time is always constant. Okay, now let's take 2 raised to n, 2 raised to x. Okay, look at this, 2 raised to x. Now remember at the beginning we saw the Fibonacci program, and I told you it takes 31 years, because that code that I showed you at the beginning has a time complexity of 2 raised to n. Okay, which means for every input, like for n, the time it takes increases, I mean, gets multiplied by 2. So for input size 2, it will take say 2 times. Then for input size 3, it takes 2 into 2, 4, and then 8, and then 16, and so on. It increases exponentially. Okay, this is exponential. This time complexity is called exponential. So you can see that 2 raised to n, just even for a very small input like this, less than 50 itself, it takes so much time, right? So that is why you don't want to write code that takes 2 raised to n and all. Okay, so ideally, yeah. So ideally, this was the chart. I mean, this chart gives you an example of how all the algorithms are. So as you can see, order of n and order of 1 are pretty good. I mean, order of log n and order of 1, they are good. And then order of n is fine. Okay, and then you have n log n. And then if you write algorithms in the red, you will most likely get a TLE unless your input size is small. So whenever you're programming, you try to make sure that whatever code that you write is having a time complexity in one of these. Okay, and now there are algorithms that take n square time no matter what by their nature. But in all cases, you need to be able to optimize the program so that they run in one of these time complexities. Okay, the smaller ones. And yeah, I think that's it. So okay, wait. Yeah. Before I conclude the session, I just wanted to tell something. So this was a very beginner oriented session, and as a result, there are a lot more topics. So in this session, we just scratched the surface of these things of time complexity, and we just went through the very basic stuff. So we use Big O notation, right? So Big O notation actually has a mathematical definition. It goes like this: a function f of n is said to be equal to big O of g of n if there exists some positive values c and n naught such that f of n is less than or equal to c times g of n for all n greater than n naught. Okay, now I know none of this makes any sense when I say it like this. And I didn't want to give you any panic attack or something on hearing all this. So that's why I didn't cover all that at this session. It's out of scope for this session, but it is something that's pretty important, especially if you are in computer science and you would learn it in your data structure subject, you would be having it. So you can, I will give you some resources like links to some videos or something and some some articles that explain these topics as well. These are some more topics that you can explore. And since we are a bit short of time, and also that this is a very beginner session, I didn't go in much into these topics. So yeah, I'll give you some resources for that. And thank you. Thank you for having me here. Thanks to TLE MEC and the training cell for organizing this event. I will share resources. And one more thing, I have made a small test, like an assessment, just 10 questions on time, on whatever we learned here so far. I'll put the link to that. And if you need certificates, please attempt this test. It just takes 30 minutes. I mean, it won't take 30 minutes. The test is 30 minutes long, but you can do it pretty soon, just 10 questions. 1 minute, let me just find the link to that. I think I can stop sharing now. And I'm so sorry, I was a bit not on time because we needed to stop by 7:30 and there were some more questions that I missed out. But I'll share the slides, and if you have doubts, you can reach out to me. And the contest. Okay, wait, the contest. Yeah, the link to the contest, I'll put it in the chat. Just a minute. It's on Hacker Earth, so some of you may have heard of the platform. I put the link. Oh, wait. Send to everyone. Okay, we'll send the link this to your registered emails also, don't worry. So I've put the link to the contest in the chat. And this not a contest, it's just a test on whatever we have learned so far. And 10 questions on time complexity, and I'll share the slides also. 1 second, let me share. So I'll share the resources of the session. That's the one. Yeah, okay. That the doc that I just shared contains the slides and the link to the contest and some more the topics that I just mentioned. Yeah, okay. Regarding the YouTube, yeah, this video, this session was recorded, so it will be available on the TLE MEC YouTube channel very soon. So yeah, thank you so much for being so active in the chat, and thank you so much.
All right. Hello. Am I audible?
Thank you.
Am I audible?
Yeah, yeah.
Yeah, okay. So I'll conclude it, right?
Yeah, one second.
Yeah,
also,
sure.
all of you, please, follow TLE MEC on Instagram. TLE MEC, like this session was conducted by TLE MEC and the training cell. So we will have more events like these, and also conduct more sessions and more events. And also we'll post some informative things on our Instagram page. So please follow us on Instagram. I'll just put the link in the chat. Yeah. And stay tuned for more sessions. Thank you. I think Sharath you can just say about the next session also at the time.
Yeah.
Okay. Thank you.
So the next session will be tomorrow, roughly around the same time. We'll have topics like what are data structures, why they're used, like Vishruth mentioned during the session about arrays, and more in detail about them with applications and problems about them. So did you all enjoy? You all enjoyed today's? Did you, if you really want to like appreciate Vishruth right now for a magnificent session, just put a yes in the chat. Like, the great job done, right? I mean, I think the numbers speak for themselves. Like roughly nearly 200 people have been sitting here for over nearly 2 hours. I think that itself should be more testament than any compliments I can give. Like, I know this topic and I sat through it, and I sat through topics I've already learned to learn them again. And I wish I had this. So yes, I think, oh wow, see the chat's so active. I thought like half of them would be dead, but they're all active. Like that's how good the session was. So tomorrow again, tomorrow we don't have Vishruth, we'll have another vibrant speaker. We'll have Pranoy from CSB some semester, and he will cover the next few topics. So stay tuned. So like Vishruth said, resources are coming, the recorded videos links are coming, and tomorrow again, a link will be posted for the next session. And so do join in for that. Same timings. Hopefully we don't extend, but then if session's too good, we may have to. We'll find out tomorrow. So thank you all for coming. Yes, that is your sign off from Training Cell and TLE MEC. See you all.
Thank you. Thank you. Thank you, everyone.